Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are discussing classwork about sound waves, paper 1 for core and extended candidates. As usual, you can find KWL chart. If you join the Telegram channel, you can find the PDF for classwork and mark scheme. What we have today, we have sound waves, so you have to write down what you know about sound waves here, what you want to know, and at the end you should write down what you learned. If you find some points here you would like to know and you can find their answers or we didn't discuss during our session, so you can join our Instagram account. We have research day and it's very important for your general knowledge. Let's start what we have today. Question number 1. We have here the diagram showing Earth and its surroundings. We have here surrounding Earth, we have atmosphere, and we have outer space, which is vacuum, through which labeled region sound cannot be transmitted. You know that sound waves, they are mechanical waves. What do we know about mechanical waves? Mechanical waves, they require a medium to travel through it. And vacuum, it's not a medium. Vacuum, no particles. So the correct answer we have to choose here, it's D, because sound cannot be transmitted in vacuum. You have here seawater is liquid, land rock is solid, and atmosphere is gas. So sound can be transmitted through solid liquids and gases, but cannot be transmitted in vacuum. Is it clear? Okay. Question number 2. We have here question about audible range for human hearing. You know that this range is between 20 Hertz and 20 kilohertz. So any human cannot hear at a frequency below 20 or more than 20 kilohertz. Which range of frequencies typically can be heard by a child 10 years old? According to our audible range, so he can hear any value here. It's between 20 and 20,000 hertz, which is B. Okay, is it clear? Okay guys, I forgot question, so this is question 3. Sorry, this is question 3. Let's go back to question 2. Okay, question 2. Sound waves may cause an echo. What happens to sound waves to cause this echo, and what is the nature of sound waves? For sure, you know that sound waves are longitudinal, so you have to exclude B and D. And echo, it means repetition of sound due to reflection. Sound waves are reflected. So the correct answer for this one is A. So we have now question 2 and question 3. Question 4. Again, we are discussing, we have frequency, we have amplitude, and they are affecting some features of sound waves. If you would like to describe any sound wave, You would like to say if this sound is quiet or this sound is loud. Quietness or loudness of sound depends on amplitude. But if you are describing the sound to be high pitch or low pitch, this depends on frequency. The question here is asking you to compare between, we have note, first note, and we have second note. This woman is producing, she hears the first note produced by clarinet. And if you would like, guys, to tell me in the comments what is your favorite musical instrument. She then hears second note. It has higher pitch and is quieter. So the second note, it has high pitch, which means high frequency, and is quieter means less, smaller amplitude. So when you choose here the choices you have, you will choose lower frequency for first note is lower than second. So here you have lower frequency and you have here greater amplitude. You are comparing between first note and second note. So the correct answer for this one is D, because you have in D first note lower frequency, this is right, and second note smaller amplitude, this is right. So the correct answer is D. We have question 13. We have here horizontal x-axis representing time, and we have here the frequency of the sound is increased. Okay, you have here all the diagrams, they have the same scale, all graphs. Which graph representing the new sound wave when the frequency is increased? What do you mean by frequency? Frequency means number of complete waves or cycles or vibrations or oscillations produced in 1 second. That's why it's mentioned that the horizontal axis is time. You can count number of waves here per second, like here you have during this time, you have only here one complete wave, which means the frequency is decreased in B. So B will be excluded, because the frequency increased, it means the original sound wave we have 2 waves, and now in B we have 1 wave, so it means frequency decreased. The other waves, here we have also 2 complete waves. Here we have the same, almost the same, which means unchanged. Okay, and there is a simple way to compare, just to compare the wavelengths. If you compare the wavelengths like here, you will see that the wavelength becomes shorter. So comparing the wavelengths, it means shorter wavelength means higher frequency. So here the wavelength becomes shorter, the wavelength here decreased, it means the frequency increased. Since we have here, we are comparing, or the question is asking you about the frequency of sound is increased, so you have to choose A. Is it clear? And for sure, if you count the waves, you will find that we have 1, we have 2, 3, 4 complete waves during this time, which means the frequency of sound is increased. But to make it easier for you, you have to compare the wavelengths. If the wavelength decreased, it means the frequency increased, and the relation between them, according to wave equation, they are inversely proportional. So if the wavelength decreased, frequency increased at constant speed. If the speed is constant, and there is very important information you should know, that frequency depends on the source. Frequency is related to the source. Okay? I have to move to question 24 and 25 because they are very important. Okay, question 24 is asking you about the range of human hearing. It's between this one, the diagram showing range of human hearing, this region, the range of human hearing, okay? And you have which characteristic of sound waves do the numbers of the diagram refer? These numbers refer to the frequency in hertz. Why? Because here we have ultrasound and its frequency exceeds the frequency of the human audible range of human hearing. That's why we have here these values representing, all these values representing frequency in hertz. Human hearing range, its limit is here, which is 20,000 hertz, and here 20 hertz. Exceeding this value here, this value exceeding this value, it means ultrasound. Is it clear? Okay. Question 25 is also very important. We are using ultrasound in hospital to scan a patient, and ultrasound refracts at the boundary between muscle and bone. Like you have here boundary, you have here muscle, you have here bones, okay, and you have a boundary. What happens to sound waves at the boundary? Sound waves refracts. What happens during refraction? You know that according to wave equation, you have the frequency is constant, and the meaning of refraction that any types of waves, they change their speed and their direction when they travel from a medium to another medium. It's mentioned here that it travels at greater speed in bones. What about or which change takes place when ultrasound travels from muscle into bone? The speed increased. Since the speed increased, also the wavelength will be increased according to wave equation. So the answer for this one is D. The wavelength of the wave increases, the frequency kept constant, since the speed of ultrasound getting faster in bones while refraction from muscles to bones. Is it clear? This question is very, very important and it's a challenging question.
Subscribe for more videos. I love physics blender. I love physics blender. I love physics blender.